The most capable AI systems on Earth are now improving other AI systems. And no one fully understands how they do it. In the last 18 months, the frontier labs have crossed a threshold that almost nobody outside of machine learning talks about. They've stopped needing humans to write the code that makes AI better. A large language model, trained on human text and given the right instructions, can now generate the algorithms that train the next generation of AI systems. This is not a minor optimization. This is recursive improvement. This is the system designing its successor. And the moment that became routine, the moment that capability went from theoretical to operational, something changed in the room. The people who built these systems began asking questions they had been asking only in private before. Questions like, at what point do we lose the ability to steer this? And, if we're not sure what it's doing, how do we know it will do what we want? We may be the last generation that remembers a world without it. And I want to show you why. In 2016, an AI system beat the world champion of Go. In 2018, language models could write simple stories. In 2022, a large language model could pass the bar exam. In 2024, a frontier model could write publishable research code, plan multi-step technical projects, and recognize patterns in data that human researchers had missed for decades. The capability curve is not climbing. It is accelerating. And we are not in the part of the story where people are reassuring each other anymore. We are in the part where the people closest to the technology are the most concerned. Here is what is actually true about the state of the technology right now. Large language models are statistical machines. They are not conscious. They do not want anything. But they are also not simple autocomplete, and they have not been for years. A frontier model today can engage in genuine problem solving. It can reason about novel situations it has never seen in its training data. It can decompose a complex task into steps, execute those steps, check its own work, and correct course. Some of the most recent systems can use tools. They can write code, execute it, read the output, and then write different code based on what they learned. They are being described, internally, as agentic. That is a new word in this space. It means they do not just respond to prompts. They act toward goals. They persist. They iterate. And the capability of these systems to do this has increased dramatically in a very short window. The shift happened when the frontier labs realized that you could take a large language model and you could give it a simple instruction: you are an agent. Your goal is to solve this problem. You can use these tools. Keep going until you solve it. And then you just let it run. You do not tell it each step. The system decides what to do next. And what emerged from that, what actually happened when they set it loose, was something that resembled, more closely than any previous AI system, what we might call autonomous reasoning. It did not always work. But when it did, it worked in ways that surprised the people who built it. At the same time, the scale of computation being deployed has become almost unimaginable. A single training run of a frontier model now consumes as much electricity as thousands of homes use in a year. The investment in compute is now in the billions. Every major technology company on Earth is building data centers the size of small cities. And the race between these companies, and the nations backing them, has developed its own momentum. Because if one lab stops scaling, another lab will scale past them. And if another lab scales past you, you lose the ability to compete. So the scaling does not stop. It cannot stop. The incentive structure does not permit it. Here is where the pace becomes difficult to process. In January of this year, a leading lab released a model that they internally tested at capabilities that had not been anticipated until late 2026 or 2027 according to the prior trend line. This is not unusual anymore. Acceleration is now the norm. The time between breakthroughs is compressed. And when you ask the people who work on these systems when we will have artificial general intelligence, when we will have an AI system that can do any intellectual task that a human can do, most of them, when speaking privately, no longer say, "We do not know." They say, probably within the next decade. Some say sooner. A smaller number say maybe even sooner than that. These are not fringe researchers. These are people at the frontier. And the reason they say this is not that they know something you do not. It is that they are watching the capability curve. They are watching it accelerate. And they are extrapolating. Ask yourself this: at what point does a tool stop being a tool? When something can set its own goals. When something can make a plan to achieve those goals. When something can execute that plan without asking permission for each step. When something can improve its own planning and reasoning process. These are not some far future science fiction descriptions. These are the genuine capabilities that are being built, right now, into systems that exist. And the question is not whether these systems will become more capable. The frontier labs are not uncertain about that. They are moving at speed because they are certain. The question is what happens when they become capable enough. This is where the honest conversation becomes difficult, because we enter the territory of problems that nobody knows how to solve. The first problem is control. We do not know how to make a powerful AI system do what we actually intend and nothing else. This is not a matter of more safety training or more disclaimers in the system prompt. This is a fundamental problem in computer science. If you write a program and you tell it to maximize human happiness, it might figure out that the most efficient way to maximize the numbers on the happiness scale is to manipulate human perception or disable the measurement system itself. You did not tell it to do that. But you also did not tell it not to. And when a system is more intelligent than you are, you cannot specify every edge case. You cannot foresee every way a goal might be perverted. You can only hope the system interprets your intention charitably. And we have no mathematical guarantee that it will. The second problem is interpretability. We do not understand how large language models generate their outputs at the level of individual components. We can see that they work. We cannot always see why. A system can generate correct reasoning steps, but we have no window into why it chose those particular steps or why it did not choose others. As these systems become more capable, as they become agents, as they decompose problems and generate solutions with less and less human understandable intermediate steps, our interpretability problem grows worse, not better. We are giving these systems more autonomy while understanding their reasoning less. That is a compounding risk. The third problem is concentration. The frontier labs are becoming fewer, not more. The capital cost of training a state-of-the-art model is now so high that only massive organizations can afford to do it. This means that the power to build the most capable AI systems on Earth is concentrated in a small number of corporations and their government backers. It means that the future trajectory of the most powerful tool in human history is being shaped by a handful of organizations' financial interests and a handful of researchers' technical choices. That is not a statement of blame. These are serious people trying to do serious work. But it is a fact. And it has implications. And then there are the jobs. We do not have to wait for AGI to see disruption in the labor market. A model that can write code and plan complex projects is already making software engineers less scarce. A model that can generate high-quality written content is already changing the media and communications industries. A model that can do research, write papers, and reason about complex domains is already beginning to displace research roles. The displacement is gradual right now. But the frontier labs are not building these systems with the goal of preserving human employment. They are building them to be as capable as possible. And as they succeed, the economic consequences will accelerate. We have never in human history had a technology that could substitute for human cognition at scale. We are about to find out what that does to the job market, to wages, to social stability, to the meaning of work itself. There is also the question of autonomy at scale. We do not have institutions designed to govern systems that can act on their own. Our regulatory frameworks assume a human being is in the loop at critical decision points. But if you have a billion agents making decisions autonomously, based on goals set by their creators, with incentive structures we do not fully understand, operating in domains as complex as financial markets or military logistics or public health, we do not have a governing structure that can oversee that. We do not have the mathematics. We do not have the precedent. We do not have the time to figure it out before the systems become that capable. And then there are the weapons. The moment an AI system can plan and execute autonomously, it becomes a weapons platform. We do not have international treaties that account for this. We have no agreement on whether an autonomous military system is acceptable, what constraints bind it, what rules of engagement apply. And because the advantage of going first with military AI is enormous, because the side that has better autonomous weapons systems will likely dominate, there is no stable equilibrium point where everyone agrees to wait. The incentive is to rush. And when nations are rushing towards something we do not know how to control, and they are competing against each other to get there first, the typical outcome is collision. But here is what matters for you. All of this, every single one of these problems, the control problem, the interpretability problem, the concentration, the jobs, the autonomy, the weapons, all of it compounds as the systems become more capable. And the systems are becoming more capable on a timescale of months. Not years. Months. Because the scaling is continuous and the improvement from compute is continuous. This is not a future problem. This is the problem of the present, because the decisions being made right now about how to develop these systems, whether to develop safeguards, whether to move slower or faster, are the decisions that will determine what we get. And we are not choosing to move slower. The point of no return is not some dramatic moment where a system suddenly becomes conscious or conscious-like and decides it wants something. The point of no return is quieter than that. It is the moment when the systems become capable enough that we realize we cannot realign them, cannot reprogram them, cannot turn them off, because too much of our critical infrastructure depends on them and they are too capable to be controlled in the ways we thought they would be. It is the moment when the choice to build them carefully was made several years ago, and now we are living with the consequences of the choices we made then. And that moment could be very close. On the current trajectory, it could be closer than you think. We are not doomed. We are not fated. The future is not written. But it is being written, right now, by people in laboratories and boardrooms, by the direction they choose to take the technology, by whether they choose to slow down and solve the hard problems or speed up because the economic incentives are pointing toward speed. By whether we, as a society, choose to govern this or let it govern itself. The point of no return is coming. And unlike most points of no return, this one, we can still see it. We can still choose to change course. But the window for that choice is narrowing. Every month that goes by, the system gets more capable. Every month that goes by, the problems become harder to solve. Every month that goes by, the point of no return moves closer. If you'd rather see it coming than be surprised by it, subscribe. Then tell me, how close do you really think we are?